According to Applied Predictive Modelling 2013, an imbalanced machine learning occurs when one or more classes have very low proportions in the training data compared to the other classes. Biased sampling and measurement errors are the primary causes of class imbalance. However, there are solutions. Here are 5 ways to work on imbalanced data learning. Let us get started. Number 5. Undersampling. Undersampling is a technique that balances the class imbalance by reducing the size of the dataset that is in abundance. Therefore, the majority is reduced until it becomes equal to the minority. To do this, the method eliminates unwanted overlapping between classes until all minimally distanced nearest neighbors are of the same class. Moreover, the runtime lessens when this happens due to the decrease in the training dataset. If you have been wondering about the memory problems, reducing the dataset will free up enough space for you. This system is a steal, especially since you will not lose valuable data by removing overlapping classes. The cluster becomes less crowded and the output stays the same. The 2 methods used in undersampling are cluster centroid and Tomek-link methods. So what if instead of reducing the abundant dataset, you increase the minority dataset? Think of it as creating rare synthetic samples to augment the not adequately represented class. It also avoids the loss of information. We will present more on oversampling to you shortly. Number 4. Cost-sensitive learning technique. Elsewhere, the cost of misclassification is valuable. Cost refers to the errors that occur in data science. The cost-sensitive learning technique minimizes the total cost of misclassification, hence it targets high accuracy. The method groups classifying examples into a set of known classes. There is a cost matrix in the technique represented by false positive, false negative, true positive, and true negatives. The matrix also has I as the predicted class and J as the actual class. CSL plays a vital role in machine learning and real-world data mining applications due to its efficiency rates. Further, it avoids the pre-selection of parameters and auto-adjusts the decision hyperplane. Number 3. Oversampling. When data is insufficient, you can balance it by increasing the rare samples. The technique that modifies the unequal data classes can organically create balanced datasets. Oversampling ensures that there is no loss of information in the process of increasing the sample size. Should overfitting be caused by the oversampling method, it automatically mitigates all the damage. If you are interested in using this method, may we recommend the SMOTE. The synthetic minority oversampling technique is where the minority class is oversampled by producing synthetic examples rather than replacements. To do this, it calculates the k nearest neighbors, KNN. The process also works on the assumption that local space between any 2 positive instances belongs to the minority class. This assumption could be wrong if the training data is not linearly separable. Thus, randomly choosing neighbors from KNN could be restricted in some areas. Actually, experts like Jason Brownlee recommended that one uses SMOTE on the minority class and undersampling on the majority class. The combination performs better than each of them individually. Speaking of combined efforts to resolve imbalanced data, SMOTE works best with other modified versions. It perfects the generalization criteria and prevents information loss. Please do not get confused. We will present that option shortly. Number 2. Ensemble learning technique. Before we tell you about ensemble learning, why don't you subscribe to the channel for more on future tech? Now, the ensemble technique combines the performance or results of several classifiers to improve the performance of a single classifier. Individual classifiers might have their strengths, but a weighted average of their combined strengths is highly impressive. The techniques combine the outputs of multiple base learners. To achieve ensemble learning, one needs to use boosting or bagging. In machine learning, bagging implements similar learners on a smaller dataset and then takes a mean of all the predictions. Boosting rectifies the weight of the observation based on the last classification. These 2 methods decrease bias and build a stronger predictive model. Meanwhile, the predictions and stability of this model are better than anybody could ever imagine. As economist Herbert Simon once said, machines will be capable within 20 years of doing any work that a man can do. Number 1. Combined class method. Class imbalance machine learning could be a challenging nut sometimes. Therefore, one could need multiple methods to solve it. In combined class methods, various methods are fused together for optimum results. Note that these methods need to have a similarity. For instance, if you use SMOTE, you can merge MSMOTE, SMOTE-TL, SMOTE-EL, or SMOTE-N. These are modified versions of SMOTE that handle different aspects of imbalance. So MSMOTE classifies the minority classes into 3 groups, such as border samples, latent no samples, and security samples. The method helps with effective generalization and avoids valuable information loss. Well, you enjoyed this video, so here is another one for you. Watch how machine translation works in providing solutions for the world.